Chapters 1 through 3 review. Starting with number 1, we need to solve for theta. Since that's the angle, then this is going to be opposite, and this is the hypotenuse. So if it's opposite over hypotenuse, that means it's sine. So sine is going to equal 12 over 15. And then to solve for sine, take sine inverse of both sides. So then we just need to ask a calculator how much is sine inverse of 12 over 15. So switch over to the calculator real quick and make sure that it's in degrees. And this one is in degrees. So sine inverse of 12 over 15, 53.13 degrees. So theta is equal to 53.13 degrees. There we go. I already got 100%. Well, at least so far. Next, it's going to be using the 37 degrees, which is also opposite over hypotenuse. This time it's going to be sine of 37 degrees equals the opposite side x, the hypotenuse 26. Then just multiply both sides by 26. And it's ready for the calculator. So 26 sine of 37 degrees. 26 sine of 37, a 15.647. So 15.647 is x, and that is all I need to do on that one. Then on to this little word problem right here. So there's a building. This can be the building, and here's the ground. And then the sun, here we go, here's the sun. So the sun is up here, and as the person looks up to the sun, it makes an angle of 63 degrees. So as the sunlight goes down like this and it hits the building, it creates a shadow on the ground, which is 38 feet. Now find the height of the building. So this is the opposite side, and this is the adjacent side, which means I get to use tangent. So tangent of 63 degrees is equal to opposite over adjacent. And then to solve for h, just multiply both sides by 38. And then it's time to use the calculator. So I need 38 tangent of 63. 38 tangent of 63, 74,579. 74.579, and that would be in feet, so that's the height of the building. Okay, what's up next? Find all solutions in 0 to 360 degrees. So that means if you look at a smart trig class, this is saying that sine is equal to a positive. That can happen right here, also in the second quadrant. So going back to this equation right here, in order to solve for theta, take sine inverse of both sides. And the calculator usually tries to give you the smallest answer, so it's going to give us the answer in quadrant 1. So what is sine inverse of 0.75? Sine inverse of 0.75 is 48.59 degrees. So one answer is 48.59 degrees, and that's the answer in quadrant 1. Now in quadrant 2, it means that the reference angle right here is 48.59 degrees. And then we need to find the, starting from the x-axis over, which means that it's going to be 180 degrees minus 48.59. So let's see how much that is. 180 minus the 48.59 is 131.41. So then it is the other answer, 131.41. And just for a little extra emphasis, that's in quadrant 2. So there are the two solutions. Now on to one that is just a little more challenging. First of all, cotangent. So this can be changed into 1 over tangent of alpha. And for the 2, I'm just going to rewrite it as 2 over 1. And I need to do that for the next step. Because in the next step, I want to invert this fraction so that it becomes tangent over 1. But if I invert one side, then I have to invert the other side. So the left side becomes tangent over 1, or just tangent, and the right side becomes 1/2. And again, using a smart trig class, it says tangent equals 1/2, so that's a positive number. So that can happen in the first or the third quadrant. So again, two solutions. The first comes from finding tangent inverse of 1/2. And do keep in mind that over here it's saying you should be using degrees. So far nothing is in radians. Tangent inverse of 1/2. That is in quadrant 1, 26.565 degrees. 26.565 degrees. That's one answer. What about in quadrant 3? So the calculator told us the reference angle is 26.565 degrees. And then we need to find the angle starting from the x-axis, go all the way over here. So this, if I stopped right there, is 180. Then you need to keep going an extra 26. So it's going to be 180 plus the 26.565. I think I could do that without a calculator. So if it was 180 plus 20, that would be 200. And then it would be 206.565. And there are the two solutions for that one. Then on to some verifying identity. So with verifying identities, you should start with the side that has more stuff. That's going to be the left side. And then simplify it until it looks just like this one, 2 sine cosine. So starting on the left side, cosine of theta plus sine of theta squared means take cosine of theta plus sine of theta and multiply it with another cosine of theta plus sine of theta. And then at the end of that, it says there's an extra -1. So then start distributing. Cosine needs to be distributed to both of these over here. So that means there would be a cosine times cosine, that's cosine squared, plus cosine times sine, next up, take this sine of theta and multiply it through with those two things. So then there would be plus sine of theta times cosine of theta. And then the last one times the last one would be sine times sine, also known as sine squared. And then that extra minus 1. Then what I'm going to do is I'm going to take this cosine squared and write it right next to this sine squared. And also, these are like terms, so you can combine them and say there are two purple ones. So in other words, there's two of them that are sine of theta times cosine of theta. And then I'll just move the cosine squared next to the plus sine squared, and then just recopy the minus 1. So this is definitely good news because that is what the answer said you're supposed to have. Then what happens to the rest? So then, let me just recopy this. Then the cosine squared plus sine squared equals 1. So then I would say plus 1. And then finally, the reason for that minus 1 at the end. Those two cancel. So it equals 2 sine of theta times cosine of theta, which is exactly what it said we're supposed to have at the end. Beautiful. Next, convert it to degrees. Also minutes and also seconds. So to convert to degrees, multiply with 180 over pi. And then the 2 pi's can cancel. And this 3 can divide into the 180 60 times. So all that's left is 2 times 60, which equals 120 degrees. And in that case, there are no minutes and there are no seconds. So you don't have to put it. It would be like if the number was 17. Well, you could put 17.0, and you could even put 17.00 if you want to, but you could just say 17. That's it. All done. Bob's your uncle. And now, what about part B? Well, the first thing is with this one, is that in radians or degrees? Well, if there was a little circle sitting right there, that would be degrees. Since there is no little circle right there, it means radians. So that means we do it like the last one, multiply with 180 degrees over pi, and then just type that into a calculator and see what type of decimal answer we get. So it's a 2.5, and then it was 180 divided by pi. So 143.239. So that means the 143 is 143 degrees. What about 0.239? So that right there is saying it's a fraction of a degree. And so if you take that and multiply by 60, it'll say 14. So now we're down to 143 degrees, 14 minutes. Now take off the 14 and just use the 0.34. 0.34 now multiply by 60 because there's 60 seconds in a minute. And then it's 20.4, and that is 143 degrees, 14 minutes, and 20.4 seconds. So at the end, after doing those calculations, at 143, 14 minutes, and 20.4 seconds. A Ferris wheel has a diameter, so this right here automatically tells me use radius equals 500 feet. It takes 12 minutes for one rotation, and then as soon as I say see that it says rotation, I automatically think in radians. That means 2 pi would be the angle. So how far would they travel after 3 minutes? Well, this is basically telling you it's a fraction of going around the circle. So they went 3 out of a possible 12 minutes, Or in other words, they went 1/4 of the way around the Ferris wheel. So if you just use that circumference equals 2 pi times the radius, and then that would be 1 full rotation, but they went 1/4 of that, so multiply by 1/4 and multiply by 1/4. So this would be, this 2 divides into 4 2 times, and then that 2 divides into this 250 times, so it's 250 pi's. So how much is that? 250 pi is 785.398, and that would be in feet. So it is 785.398, and that's in feet. Angular velocity. So that basically just uses this information and this information, because for angular velocity, you just need to know the angle divided by time. So the angular velocity equals the angle divided by the time, and then the units would be, this is radians and this is minutes. Or of course that could be reduced to be pi over 6 radians per minute. All right, what about the linear velocity? Well, there's several ways you could do this. One way is you could just say, look at part A, I found out they traveled 785.398 feet, and on part A, it took 3 minutes to do it. So that would probably be the easiest way. Distance, 785.398 feet. And on part A, it said it took 3 minutes to do that. So then I just need to divide. So actually the last answer is still sitting there. I could just say take that last answer and divide by 3. And it's 261.799. 261.799. And the units would be in feet per minute. All right, let's see what else we got. So, trying to estimate the height of a building. Here's the building. It's a very skinny building. And we just need to know what's the height, h. Then this will be the ground. At one point she found the angle of elevation to be 19, and then she moved closer. So she was standing out farther away over here, look to the top, and then the angle is 19 degrees. And then she moved closer by 25 feet, and then the angle is now 23 degrees. So assuming that the building is standing upright, this is 90 degrees, and this part right here is not known, so call it x. So now we can use this triangle right here. I love coloring. Anyway, this purple triangle, and then we could use tangent. So it would say tangent of 23 degrees equals opposite is h, adjacent is x. All right, now use the whole triangle, and then that's going to be using the 19 degrees. So then it's going to say tangent of 19 degrees equals opposite is h, and then the bottom would be 25 plus x, or in other words, x plus 25. Okay, then on this equation, multiply both sides by x. on this equation, multiply both sides by x plus 25, and it should be put in parentheses, x plus 25. And then after, let me get blue, after these cancel, that means it's equal to h. And after these cancel, that means this one's also equal to h. So if this is equal to h and this is equal to h, then they have to equal each other. So parentheses x plus 25 times tangent of 19 has to equal x times tangent of 23. And then go ahead and distribute this. Tangent of 19 times x, and then plus 25 times tangent of 19. And the right side just stays as it is for now. The next thing is, since this has an x in it and this has an x in it, put them on one side. So I'm going to put them on the right side. So I'll leave this one. And then it's going to say x tangent of 23 was already there, and then subtract x tangent of 19 degrees. And then on the right side, you could factor out x. So that would leave tangent of 23 degrees minus tangent of 19 degrees. And then to solve for x, all we need to do is divide both sides by this tangent of 23 minus tangent of 19. So 25 tangent of 19 gets divided by tangent of 23 minus tangent of 19. And that is what x equals. Now hopefully I can remember by the time I go to the calculator. Okay. It was 25 tangent of 19. Hey, I typed a 9, didn't I? There we go. Tangent of 19 gets divided by, and then tangent of 23 minus tangent of 19. All right, got all the parentheses and everything. Oh, it looks like I missed one right here. Sorry about that. Insert a parenthesis. 107.405 is what x equals. So this equals a 107.405, which is not the final answer, because that is what x equals. So now what we need to do is take that 107.405 and substitute it here. So the final answer is going to be in this little box right here. Just barely got enough room. That h equals the 107.405. And then substitute in that top equation for x, so it says then times tangent of 23. And got just enough space to do it. So take this last answer, 107.405, and multiply with tangent of 23. And final answer is the height of the building is 45.591. 45.591 feet. Ta-da! And then, I think this is the last one. Oh, no, it's not. Sorry. So given that secant equals 3, find the exact value for tangent. So there are several ways you could do this. I haven't done this for a little while, so I think I'm going to use 1 plus tangent squared is equal to secant squared. And then on the right side, just substitute secant squared means secant gets squared. But according to this, secant is equal to 3. So on the right side there is a 9, and then subtract 1 from both sides. So the left side says tangent squared equals, and then this would be, on the right side would be 9 minus 1, also known as 8. And then take the square root. When you take the square root of both sides, put plus or minus the square root of 8. And then for 8, it could be factored as 4 times 2, so this is actually plus or minus. The square root of 4 is 2, and the square root of 2 is the square root of 2. So the last part is it supposed to be the positive one or the negative one? So, a smart trig class, this is quadrant 4, so that means cosine is supposed to be positive, tangent is supposed to be negative. So it's negative 2 square root of 2, that's the exact answer. And the old ultra runner. So from the north, go towards the west by 22 degrees. And then make a right turn, so going this direction, and then run 12 more miles. Oh, I forgot to write, this is 10 miles here. And this is a right angle, and the person ends up over here. And then what bearing should they take to get back to the start? So from here back to the start, then what's the bearing? Well, before I start talking about bearing, what I should do is say, how much is this angle right here, theta? So if you look at the whole picture, it's got, this is the opposite side, and this is the adjacent. So that means I could use tangent. So tangent of theta is equal to 10 over 12, opposite over adjacent, and then take tangent inverse of 10 over 12. So tangent inverse of 10 divided by 12 is an angle of 39.806. So theta is 39.806 degrees. Let me just double check. 39.806, is that what I said? It is. All right, but that's not the bearing. The bearing means if you go from this north-south line and then you want to tell the person from the south line, go this many degrees until you're running on that line right there. So then, what angle is this? Well, I could use the fact that because the north-south lines are parallel, then this angle is the same as this angle. So, I know what the theta is, I know the 90, I know the 22, I just don't know this x right here. But because the three angles of a triangle, this angle, this whole angle over here, and this angle over here have to add up to 180, then I could set up an equation and solve for x. So it would be that x plus 22 plus 90 plus the theta, 39.806, all of that has to equal 180. Or in other words, x is equal to 180 minus the 22 minus the 90 and also minus the 39.806. So 180 minus 22 minus 90 minus 39.806. Sorry, I knew I wasn't going to remember that one, so I had to write it down. Now go to the calculator. So 180 minus 22 minus 90 minus 39.806. And that is 28.194 degrees. And then we're practically done with that one. So x is equal to 29.194 degrees. So again, this x right here is the same as the question mark. So that means this angle in here is saying from the south, go towards the west by 29.194 degrees towards the west. That is the direction they should run. Oh no, I'm out of problems. Oh, well, I guess we're finished then.